Hello and welcome to a rapid deep dive on Docker. What I'll cover in this course, I'll start with Linux containers, which is also known as LXE, and then I'll talk about Docker image, Docker engine, Docker containers, registry and repository, Docker storage volumes, and understanding networks. Since this course is a rapid course, I would like to seek for your laser focus attention along with your 4 GB RAM machine. About the author. I'm Krishna Kumar M. I'm a technology evangelist and part-time freelancer. I started my career way back in 1995 as a programmer in C and C++ on Unix Linux platform, and then contributed on various system and application programming along with Y2K issues. Then later on I get into an application development phase using VB and VC++. And then I moved into IT infrastructure space and contributed on various solution deployments on Core.io, API.io, and BPI.io, etc. Then later on, I plunged into modern technologies, and then I contributed and deployed various virtualization and cloud computing infrastructure with the help of DevOps. Currently, I'm practicing on mobility architecture and automation on native and omni-channel solutions, pay-as-you-go app on pay-as-you-go business model, etc. Underneath the bottom line, you will find various endpoints of mine. Using any of these, you can easily reach me. Section 1, Linux containers. In these containers, I'm going to talk about traditional IT model, virtualization model, and Linux containers. A little bit comparison about virtualization and Linux containers. And then I'm going to talk about namespace, control groups, capabilities, etc. So before getting to Linux containers, I will talk about the traditional IT infrastructure. So what for we need IT infrastructure? Eventually to deploy an application or multiple application, right? Yes. So let's say, for example, any of your business unit head wants to deploy a single application in your environment. So they already, place their order to us. We as an IT supplier for the organization, we'll have to procure a server for this, and of course we need to dedicate a rack space to mount the server. In case space is not there, we'll have to think about procuring rack, and of course we need to buy an operating system, either Windows or Linux. Then of course you need redundant power supply, cooling, storage system, and networking and storage ports, and of course PO for raising all these things in your internal procurement deployment. In case if this application to be deployed on a high available mode, we need 2 sets of PO to be raised. So even after this, after 2 months you deployed the application successfully, and after 2 months when you take the utilization report, you'll be shocked to see only 10% of your server is being utilized. What a waste of your technology, your resource, your power, your storage, etc. So this is the ultimate disadvantages of your traditional IT model. So to get rid of this, or to come out from this, there is a revolutionary technology brought in called virtualization. So in virtualization also we need all the set of physical server, rack space, etc. But in this case, we can leverage a single server to the fullest. For example, always 80% of your single server will be utilized with the help of a technology called hypervisor. So hypervisor is nothing but using a single hardware, you can segregate the hardware into various segments, and then each and every segment will be dedicated for an application or multiple application. So in hypervisor, there are a couple of models. One is type 1 and type 2. Type 1 is nothing but a bare metal model, wherein you can deploy a minimal set of operating system will be deployed, and then which has got user mode as well as kernel mode. So type 2, you have to install an hypervisor as a tool on top of your operating system. In a commercial model, I would say like VMware ESX ESXi is the example for your type 1, and then Microsoft Hyper-V is the example for your type 2. So this is the basics of virtualization, and now we'll see what is containers. So container is also nothing but a OS level virtualization method for running multiple isolated Linux system. So here in any operating system, if you see, there are a couple of mode. One is user mode and the other one is kernel mode. Kernel mode is nothing but a set of tools and programs which will talk closely with your hardware resources such as RAM, motherboard, your memory, your hard disk, etc., your storage, etc. User mode is nothing but all your user related stuffs, your file system, your bit tree, your process trees, I mean your networking, all those things originates from there. So these are the two different modes. In user mode can be isolated, can be segregated, can be separated into an isolated runtime environment, which is nothing but a container. Meaning isolated here meaning each and every container is having a root file system, for example, etc, var and proc, etc. And then we have a bit tree, process trees, and we have a networking. So which is isolated per container. And then isolated also has, there is no communication between container 1 and container 2. Of course, there are technologies to communicate between these two that I will cover later in the future videos, but not in this Docker course. Each and every container is unique and isolated in nature. These containers are also known as secured isolated application runtime environment. So each and every container has got the capability to deploy any runtime of an application, especially on Unix, Linux applications, right? It has a single kernel, meaning in operating system, as I already mentioned, you have two modes. One is kernel mode and a user mode. In user mode, we are going to segregate this container in kernel, but all these user mode, all these containers are going to share a single kernel, same like your hypervisor. So it is less lightweight than your virtual machines because it consumes very less resources than your virtual machines. I will let you know what is very less resources in few minutes. In some places, to distinguish from hypervisor, people used to call this as or referred it as container virtualization or OS level virtualization. Can we say that hence containers are better technology than virtualization? But wait a second, when virtualization provides better utilization of hardware resources, then why do we need a containerization technology? A question raised now, right? That's correct. Absolutely, it's a good question. Let's see with an example. We all know that infrastructure is built for deploying application or multiple applications. Traditional model is it is not efficient enough. It's a huge waste of system resource. So we are not going to use our traditional model for this example. So we brought in virtualization. And then in this example, we are going to see or we are going to deploy 6 different applications such as MySQL, MongoDB, Redis, Apache, Tomcat, and of course Nginx. These are the 6 different Linux applications to be deployed on a virtualization environment. Make a note of this point, virtualization environment. Okay. So in this model, we are going to install operating system for each and every application. Let's say this is onto your right, you will find a hardware underneath, and then on top of it, you have a hypervisor type 1 or type 2, doesn't matter here. And then we are allocated, set of resources for VM1 through VM6. And then we are going to deploy operating system for each and every allocated virtual machines. These are the operating system. All are going to be your Linux operating system. So in this case, to install an operating system, we need to allocate 20 GB of your storage, for example, in our example, and 8 GB of RAM and 10% of CPUs are going to be CPU. These are the 3 resources are going to be allocated for one particular VM, right? To install one particular operating system. So for installing 6 different applications, we need 120 GB of your storage and 48 GB of your RAM and 60% of your CPU are going to be dedicated for these 6 applications, right? I would say this is the traditional disadvantages of your virtualization because so we need to dedicate this much of system resources before even start the installation process of your operating system or single before even think about installing or deploying a single application. So this is what, so we need to dedicate huge resources here in order to deploy 6 different applications. And here is where container differs, as it is fundamentally different in comparison with virtualization model. Hope you would have got the point. Until next time.